Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you for so much for the confirmation, everyone. So, before we get started, let me quickly introduce myself to you all first. So, my name is Neeraj Kheria, and I have been working in this IT industry for more than 13 years now. So the main agenda for today's session, we are going to start with discussion on why exactly we need big data testing, and then we are going to discuss on what exactly is big data testing. Then we are going to discuss on strategies behind big data testing, big data forms, big data testing environment, testing big data testing tools, and then the challenges faced in testing big data testing versus traditional testing that we have. So we can say the never-ending search for creation, storage, retrieval, and analysis of humongous volumes of data triggered the motivation behind the origin of big data testing. So most of the users might end up with one question that asks why exactly we need big data testing, and you may have got multiple answers for that as well. So let's understand this by a simple use case. Let's assume a classic case of a drastic failure that occurred in a bank. Now, the designers of the bank database named the customer bank location PIN code as CL. So the customer bank location PIN code was named as CL, and customer ID column as CI, and the customer phone number as CP. So let's go to our annotation mode to have a quick clarity on that. So let's assume a classic case of a drastic failure in a bank. So the designers of a bank system, what they did, they simply have used multiple acronyms. For example, let's say for the customer location, for example, let's say if you talk about customer bank location PIN code. Now, this customer bank location PIN code, they have mentioned this as CL. Customer ID, suppose if they have another column defined as customer ID, so customer ID has been defined as CI. And then we have customer phone number. So if we have customer phone number, so this column has been saved as CP. This column has been saved as CP. So now the bank wants to make a key value pairs of customer ID CI and customer phone number CP, a key ID from the customer ID and customer phone number as CP. So in this scenario, the map reduce algorithm mets up between the letters P and L due to typing error. Let's say if we were typing as CP and now instead of CP we have mistyped CL. Then CP, customer phone number, is replaced with key value pairs CL, because for CL we define customer bank location PIN code, right? And now the customers won't get the OTP and phone banking facilities, correct? It may happen just because of a mistypos. Now, instead of getting the customer phone number, we have used customer bank location PIN code. And that's why the customers are not going to get the phone banking OTP. And if we talk about this in real-time situation, so again, this is going to be a blunder. So to avoid such mistakes, we prefer to test the big data components, and that exactly is why we have big data components defined. So if we talk about what exactly big data testing component is, then big data testing can be defined as the procedure that involves examining and validating the functionality of the big data applications. Big data is a collection of a huge amount of data that traditional storage systems cannot handle. And testing such a huge amount of data would take some spatial tools, techniques, and terminologies, which will be used in the later section of this entire sessions. All right, so Now, if we talk about strategies behind testing big data, then it involves multiple things. So testing an application that handles terabytes of data would take the skill from a whole new level and out of the box thinking. And the core and the important tests are that the quality assurance team concentrates is based on three scenarios. Namely, we have to have a batch data processing test. First of all, it has to be a batch data processing test. Then it has to be real-time data processing test. And then thirdly, we have interactive data processing test. Now let's discuss on what exactly these three tests are step by step. So if we talk about batch processing test, then batch processing test involves testing procedures that run the data when the application in batch processing mode, where the application is processed using the batch processing storage units like HDFS. And batch processing testing mainly involves running the application against faulty inputs and then varying the volume of the data. So if you talk about the second component as in real-time processing, then real-time data processing test deals with the data when the application is in real-time data processing mode. So the application is run using real-time processing tools like we have Spark, which is mainly used for real-time streaming data sets. And real-time testing involves the application to be tested in a real-time environment, and it is checked for its stability. And then we have interactive data processing test. So the interactive data processing test integrates the real life test protocols that interact with the application as in the view of the real life user. Interactive data processing mode uses interactive processing tools like Hive SQL. Next, we have big data forms. So big data gains its fame through its superiority in handling multiple formats of data, which the traditional data processing units fail to handle. And the data formats which the big data can handle are multiple. Like it can handle structured, semi-structured, and unstructured data sets. So if we talk about structured data sets, then any tabular data which is meaningfully organized under rows and columns with easy accessibility is known as structured data sets. It can be organized under the named columns in different storage units such as RDBMS. So for example, we have the e-commerce data, we have the employees details. So any data in the format of table in rows and column, again, they are a part of structured data set. They are going to be part of structured data sets. And then we have semi-structured data sets. So semi-structured data lies perfectly in between the structured and unstructured data. It cannot be directly ingested into an RDBMS as it includes metadata tags and sometimes duplicate values. Data needs to be have some operations to be applied to it before data is ready to be ingested. For example, we may have XML data, we may have data coming in from multiple emailers, we have email data, right? These all are examples for unstructured, or we can say semi-structured data sets. Whereas if we talk about unstructured data, then data does not obey with any kind of structure that is known as unstructured data. So they include images, video, audio clips. So again, these all are examples for unstructured data set, and they make up of almost 80% of all the available data sets globally. That's how they are structured. Next, we have big data. As we discuss here, again, structure includes data warehouse, database, ERP, CRM solutions. Semi-structured includes CSV, XML, JSON data. Then we have unstructured, which includes audio, video, and all the images. That means all the multimedia elements. Now, let's talk about big data testing environment. So owning the perfect environment for testing a big data application is very crucial. So the basic requirement that makes up data testing, we can say unique and useful are. So first of all, we should be having space for storing, processing, and validating terabytes of data that is available for us to process. The cluster and its respective nodes should be responsive, and data processing resources like the powerful CPU should be available. Because, and again, even in terms of storage, we should be having a good performance storage. Let's say we are trying to perform a real-time analysis, then we need to make sure that the disks that are used for storage, again, they are high performing high SSDs for the real-time performance. But in case we have large batch jobs, like we have a large jobs run that is going to run in batches, then we can make use of a high performance hard disk to maintain a balance between the pricing and the performance as well. And the general approach to test a big data application involves mainly three different stages. We have data ingestion, data processing, and then we have validation of the output. So first of all, if you talk about data ingestion, then data is first loaded from source to big data system using extracting tools. And then the storage might be HDFS, MongoDB, or any other similar storage. Then the loaded data is cross-checked for errors and missing values. A simple example can be talent server, like we have talent. Then we have data processing. So in this stage, the key value pairs for the data gets generated. Later, the MapReduce logic is applied to all the rows and checked if the algorithm works fine or not. And a data validation process takes place here to make sure that the output is generated as expected. And then we have data validation. So at this stage, the output generated is easy to be migrated to the data warehouse. And here the transformation logic is checked and data integrity is very well verified, and the key value pairs at the location are validated for accuracy. Now, after that, we have multiple phases that we have to work on. So even in validation of the output, there are many categories involved in which big data application can be tested. So we have unit testing, functional testing, non-functional testing, performance testing, and architecture. So first of all, if we talk about unit testing, then unit testing in big data is similar to any other unit testing in simpler applications. So the complete big data application is divided into smaller segments, and each segment is tested thoroughly with multiple possibilities for an expected outcome. And if the segment fails, then it is sent back to the development and improvements. Then we have functional testing. So functional testing can be otherwise called as the different phases in testing the big data application. So big data application is designed to deal with huge blocks of data, and such a huge volume and variety of data is often prone to bring data issues such as bad data, duplicate values, metadata, and missing values and whatnot. And this is exactly why the pioneers in testing and big data designed the procedure for functional testing of big data. And the different phases in which the big data is tested includes data validation phase. For example, first of all, we have data validation phase. Then we have data integrity phase. Then we have data ingestion. Then we have data processing phase, and then we have data storage phase and report generation phase available. So if you talk about data validation phase, now before we move further, so let's have a quick review, or we can say overview for these different phases. So in terms of data validation phase, we know that data validation phase deals with the business logic and layers in big data application, and the data is collected from the source and it is run against a business use case, and data is collected and checked for accuracy and movement through the layers of applications. And at this stage, the big data unit is tested with aggregation and filtering mechanisms. The data undergoes end-to-end validation and transformation logic based on business rules. Then we have data integrity phase. So data is checked for completeness with referential integrity and validation, and data constraints and duplication is verified against error conditions. And then the boundary testing is done, which recognizes schema limits for each layer. Then we have data ingestion phase. So under data ingestion phase, the ability of the application to connect with different data modules is checked, and data is replayed with the messaging systems, and any loss of data is monitored. And then the main motto of this phase is to achieve the following qualities. For example, we have fault tolerance, continuous data availability, and then we have stable connection with a variety of data streams. And then we have data processing phase, where we carefully examine and execute the business logic. The business rules are cross-validated. The map-reduce logic is validated at every stage, and data is processed from end to end, and the application is checked for any exceptions, and they get perfectly handled. And then we have data storage phase, which concentrates on the following parameters. So basically we have read and write timeouts, conditional availability, load balancing, and query performance analysis given in the data storage phase. And then last we have report generation, where we take care of real-time reporting, data drill-ups, and business reports and chart generation. Next we have non-functional testing. So the non-functional testing phase takes care of three major dimensions and characteristics of big data. First of all, we have volume, velocity, and finally the variety of big data. And there are 5 stages involved in non-functional testing. First of all, we have data quality monitoring, the infrastructure, data security, data performance, and then failover test mechanism. What we discuss here, first of all, we have data quality monitoring, then we have infrastructure, then we have data security, then we have data performance, and then we have the failover test mechanism. And then we have performance testing. So performance testing highly concentrates on the performance delivered by all the components of the big data systems. And performance testing includes data collecting phase, data ingesting phase, data processing, and component peripheral testing. These are the main components for performance testing. So if you talk about data collecting phase, then it is based on the speed and capacity to grasp data within a given time frame from different sources. Like we have RDBMS, we can have databases, data warehouses, and many more. In data ingestion phase, so basically here the application is tested and validated based on its space and capacity to load the collected data from the source to the destination, which might be HDFS, MongoDB, Cassandra, or any other similar data storage unit. And then in terms of data processing, the application is tested based on the map reduce logic written. So the logic is run against every single node in the cluster, and the processing speeds are validated, and the queries to be executed are expected to perform with high speeds and with low latencies. Whereas in terms of component testing, or can say component peripheral testing, so the stage is related to component performance. Each component in the system should be highly available and connected, and the component backup should be online when any node faces failure, and high capacity data exchange should smoothly be supported. Now, in terms of performance testing approach, first of all, we have to start the application. Then we have to work on designing the dashboard, connecting clients, running an analysis, and with the final configuration. So basically, we can start by creating a big data cluster and running the application. Then we have to work on designing the workload required to run the test. And then it involves clients in the test and takes so that we can get their feedback. And then we have to execute the application with the data and analyze the results. And if the application is performing with optimum stability, then the process is finished. Else, apply the regular or can say required modifications and retest the same application again. And these all are different parameters that are involved in performance testing. First of all, we have data storage. So basically, we have to take note of orientation in which data gets stored in the system. Then we have commit logs. So commit log, basically here we have to mark the limits for committing logs. Then we have concurrency. So where we are going to check the number of threads allocated for the read-write process. And then we have caching, which is going to dedicate the row cache and key cache. And then we have timeout. So here we set the timeout for the application connection and queries as a part of the parameters for performance testing. Next, we have architecture testing. So architecture testing concentrates on establishing stable Hadoop architecture. So the architecture for big data processing application plays a key role in achieving smooth operations. Poorly designed architecture leads to chaos like performance degradation, node failure, high data latency, and may require a high maintenance as well, right? And in terms of the testing tools available, there are multiple tools available. So in terms of tools, there are multiple tools for data ingestion, processing, data storage, and data migration. So as we discussed, there are multiple tools available for data ingestion. We have tools like we have Zookeeper, we have Kafka, we have Scoop. Then for data processing, we have MapReduce, we have Hive, and then we have Apache Pig. For data storage, we have Amazon S3 and HDFS being the Hadoop distributed file system. Whereas for data migration, we have Talend and then we have CloverDX. So these all are the main tools offered under big data testing. So now let's discuss on the key challenges faced here. So the biggest challenge faced in big data testing is big data testing is highly complicated and the process requires a highly skilled official. That's the first challenge. Big data, again, if you talk about automated big data testing procedures, then they are predefined and they are not suited for unexpected errors. Next, we have virtual machines. Latency creates latency in test, and managing multimedia is basically going to be a hassle. The volume of data is one major challenge for testing, and the test environment and automation should be developed for different platforms, and each component is from a different technology, hence requires isolated testing, and no single tool can perform end-to-end testing, and high degree of scripting is required for designing test cases, and customized solutions are required to you can say increase performance and test critical areas. So if we talk about the traditional testing and big data testing comparison, again, first of all, we have big data testing supports all type of data testing, and it supports only structured data testing by default, whereas if you talk about the traditional testing scenario. Whereas if you talk about the other advantage, then again for big data testing, again the big data testing approach requires research and development, whereas traditional testing data doesn't need any research and development because they are built for small use cases. Then if we talk about the data size, then data size is unlimited in big data, whereas we have limited size of data available that we can process in traditional testing. Whereas in big data test, we require spatial environment for testing. And in traditional data testing, we don't need to have any spatial environment created. Then only the highly skilled and qualified candidates are preferred in big data, whereas someone having even a basic operations knowledge, that person is going to be enough in order to run the given test. So let's say we look at how exactly we can work with something called as PiSpark. So let's say we know that PiSpark again is an integral component for any big data solutions. So when now we have already configured PySpark in our cluster, and that exactly is why we can simply trigger PySpark. So PySpark, we know it's basically a Python API for Spark system, and we know that Apache Spark, they are used for real-time processing. When we have a continuous streams of data coming in, and we have to process that data and that too in as quickly as possible, then we can make use of Spark systems. So here we are going, so here PySpark is something on, we can say a small combination of Python with Spark architecture. So basically we can use PySpark through which we can easily integrate and work with RDDs as in resilient data sets and in Python programming language. So let's say as a small hands-on, we want to work on multiple RDDs. RDDs is again something that we use as an integral component available in Spark. So when we say RDDs, it simply means resilient distributed data sets. So let's say if we talk about a small example for how we can manipulate RDDs by using PySpark. So let's say we have a small data set. Let's say we want to perform multiple transformations on the RDDs. So let's say here we can create a small data frame. Let's say our goal here is to create a small data frame. So we can define data. Now, under data, by using the Spark context as an SC, we can simply run parallelize operation. And let's say if we have a small message that we want to run this entire transformation on. So let's say we have a message as welcome to Edureka. So we have a small message and now we want to split this message here. So here we can run the split function and then we can define how exactly we want the message to be split. We want to use the space. So suppose if there are multiple commas available here, then we can use comma. But currently we don't have any comma in this sentence, so we have only spaces, right? So we can use space to split the entire sentence. Or for example, let's say here we add a message for hi everyone. Suppose here we add two words more. Hi everyone. So let's say we have this sort of messages available here, and now we want to split the entire sentence into smaller components by using split command. And for splitting the entire statement, we have to simply define the space parameter. So using space, we are going to split that command for us. So now after the line is going to be split, then we are going to map it. For example, let's say a simple operation, we want to create another modified data set. So here we can define modified data, and then we can define data.map, where we are going to make use of lambda function. So using lambda, let's say we want to check if the word contains. So let's say we want to run a small analysis, a small job, where we want to check if the given data. Now we can also use a complete large data set, or for a small example, we can refer to this line. Let's say we want to check how many words they start with letter E, and then we want to cross check each and every letter. If the word starts with that specific letter, let's say letter E, then we are going to see the value true as return, or it is going to return false. So for that, we are going to make use of map. So map is basically used to return a new distributed data set formed by passing each element of the source through a function. That is what we use it for. And then here we can define the logic. So first of all, we can define lambda. Here we can use lambda, and then we can define logic as word. First of all, we can define the word as stored as at zero index value. So here we define the entire word part. Now here we can define word. Now here we want to sort out the word which starts with a specific letter. So here we can define starts with. Now we want to check those words which starts with, let's say, letter E. So here we can define E. Okay, we had mistyped this. So let's correct it up. That's why we have to make sure that there is no typos, because again, if there's a simple typos error, then this is going to return an error. Now we can see this entire statement has been executed. Now we can run to see the result. We can define modified data dot collect, and then we are going to see here we have modified underscore data dot collect, and then based on the logic that we defined here, we would be able to see the result. So now the entire statement, that means here we had defined the data. Now this has been split into each and every single word, and now it is being cross-checked for the word E. Now high starts with H, so it doesn't start with E. That's why it has been returned as false. Everyone starts with E, the same logic that we defined here. That's why it has been returned to true. Welcome starts with W, so it is false. To starts with T, it is false. Edureka starts with E, and that's why it has been returned as true. A simple job for working on large data set, and when we want to have a good and real-time stream of processing done, then we can make use of Spark system here. And let's say here we want to apply filters as well. For example, here we can define, now if you want to return only the given statement, so here we can define modified data dot filter, and here we can apply multiple filter. For example, here we want to define lambda answer, and now we want to return only those answers which are true. So here we can define 2 dot take 2. So basically this is going to return only that answer which is going to be defined as true for the given response. That's how it is going to return only that particular statement. Not now, earlier we had checked for the true or false value for each and every statement, and now we are going to check on, now we want the data to be returned only for those values which has been defined as true only. As you can see here, now it says everyone where E is true and Edureka where E is true as well, as a part of performing filters as well. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye bye.